Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So how does the energy stored in a capacitor change if the potential difference is doubled and if the separation of the plates is doubled? Okay, well, the capacitor is charged and isolated, so the amount of charge on the capacitor is not going to change here. And the stored energy is going to be given by equation 17-10. And that says that the stored energy, we're going to call it PE or potential energy, is equal to 1/2 times the charge, Q, times the potential, V. Well, if we double the potential for part A, we'll call this PE prime. It's equal to 1/2. Again, the charge doesn't change. So Q multiplied by 2 times V, which is equal to QV. Well, comparing that to what we originally had, that's equal to 2 times the original potential energy, PE. So it's doubled, and we can box that in as our solution for A. Okay. Now, for part B, we're going to rewrite the stored energy, where the stored energy, PE, is equal to 1/2 times Q squared divided by the capacitance C. Okay, well, if, again, the charge doesn't change, the capacitance would be reduced by a factor of 2 if the plate separations were doubled, right? Because it's a direct function of the plate separation. So because C is a function of 1/d, inversely proportional, if the plate separation is doubled, C is halved. So PE prime here, in this case, would be equal to 1/2 times Q squared divided by C over 2, because it's half of C, which C over 2 is equal to C on the bottom multiplied by, you'd have 2 on the top. So the 2's are going to cancel, and this is going to be equal to Q squared over C. Okay, well, that is comparing it to the original potential energy 2 times the original potential energy, PE. Therefore, for part B, it is also doubled. And box that in as our solution.